Hello, welcome to this video. This is for Study Booklet again. This is May, June 2021. Let me write that down somewhere. May, June 2021, and it's question or paper 23. Suggest and explain why the vapor pressure of water at room temperature is lower than the vapor pressure of methanol at room temperature. Refer to the correct intermolecular forces. Good question. All right, first of all, what is vapor pressure? Now, the vapor pressure is the pressure exerted by the vapor above a volatile liquid. Okay? Now, what does that mean? Some fancy words, but what does it mean? Well, where do we always go to in chemistry? A beaker. Two beakers. Okay, and in one, there's the surface of the beaker. Sorry, the surface of the liquid. In one beaker, we've got these molecules. Okay, and in another beaker, we've got these molecules. And they're obviously going to be different molecules. I don't know what they are yet. Well, I do. In this one, that represents water, a water molecule. But in this one, what do they ask for? Is it methanol? Is it? Yeah. In this one, it's methanol, CH3OH. Now it's telling us that the vapor above the water, there it is like that, but it's telling us that the vapor above the methanol is greater. So there are more particles above the methanol than there are above the water. Okay, now interestingly, this is a physics thing, isn't it? When the saturated vapor pressure is equal to the atmospheric pressure, okay, when that happens, the liquid boils. Liquid will boil. Okay, so let's say, I don't know what temperature should we call this? Let's call this 50 degrees C. Okay, so at 50 degrees C, water has fewer particles above it than methanol does. Okay, now these particles here are the water molecules, and these particles here are the methanol particles, but they exert a pressure, and that's known as vapor pressure. Okay, so which one is closer? Which one do you think, looking at these two pictures, which one do you reckon has the highest vapor pressure at the moment? Okay, well, it's going to obviously be this one, isn't it? This one has a higher vapor pressure because there's more particles in it, and this one has the lower vapor pressure. Vapor pressure. Okay, so the one on the left, the water has a lower vapor pressure. The one on the right has a higher vapor pressure, both at 50 degrees C. So if I continue to heat this up, let's say go to 60, all right, and then to 70, what's going to happen to the vapor pressure of both of them? Well, as we increase the temperature, more molecules are going to enter the vapor stage, and therefore increasing temperature. Temp increases, vapor pressure will also increase. Okay, but which one do you think will reach atmospheric pressure first? Well, it's obviously going to be this one because it's already got a head start, as it were. The vapor pressure above the methanol is already higher than the water. So if you heat them both up, the methanol vapor pressure will reach atmospheric pressure before the water um, vapor pressure reaches atmospheric pressure. So which one will boil first? This will therefore boil first. Now, I don't know the boiling point. Boiling point of water, we know, don't we? 100. But the boiling point of methanol, I don't know. I know ethanol is 78, so I'm going to assume it's less than that. I don't know, let's say 70. I don't know what it is, though. All right, so there you go. That's what causes something to boil when the vapor pressure is equal to the atmospheric pressure. Now, the question doesn't really answer that, though. It says why, what's going on? Right, obviously, why can a water molecule leave? It obviously must break bonds between the water here and the water and it goes up there, doesn't it, to form the vapor. Same with the ethanol. Okay. Now, the intermolecular forces that the question talks about, in both cases, are hydrogen bonding. Hydrogen bonding in both. That's the first thing. Now, but it's obvious because water has a lower vapor pressure at the same temperature. The hydrogen bonding in water, the H bonding in water is stronger than the H bonding in methanol. Now, maybe you didn't know that, but I'm telling you now it's true. It is. So, because the hydrogen bonding in water is stronger than that in methanol, less atoms, or less molecules can leave the vapor, can leave the liquid and go into the vapor. Therefore, the vapor pressure of water will be lower than the vapor pressure of the methanol. Now, why is this? This is a bit more technical now. Right, now, it's obviously a hydrogen bonding thing, but there's a water molecule. Okay, and there's a hydrogen bonded with another water molecule and a hydrogen bonded with another water molecule. But methanol, CH3OH, and there's another methanol, CH3OH, okay, there, and I don't know, let's do another one. There's a hydrogen, there's an OH there, CH3. Now, water is a smaller molecule, but it can form more hydrogen bonds because it's got two hydrogen atoms per molecule. Now, methanol has only got one hydrogen atom per molecule. Now, obviously, you're going to complain, what about these three? Well, these three hydrogen atoms don't take part in hydrogen bonding. So because water has, there's more availability of hydrogen atoms, it can form more hydrogen bonds. So therefore, the hydrogen bonding of water, in water, between water molecules, is stronger than that, than between methanol. So these can form more H bonds. So on average, you're going to have more H bonds in water, and this one is going to be less H bonds, and that's why the vapor pressure of methanol is is more than the vapor pressure of water at the same temperature. Thank you.